Welcome to your lesson on area of parallelograms for Pre-Algebra Chapter 10, Section 1. Today we're going to be talking about area, specifically of parallelograms. We've talked about these types of shapes before, and if you guys remember, a parallelogram is a quadrilateral, meaning four sides of a four-sided figure that has two pairs of parallel sides. Here's an example of a parallelogram. This one's also called a rectangle, right? Where I have two sides that are parallel and another two sides that are parallel, so that makes this a parallelogram. Now we want to find the area of this parallelogram, and what we're going to do is we want to actually figure out how much space is on the inside. We've talked about perimeter before, where perimeter is the distance going around the outside of a figure. But today we want to talk about area, so all the space that goes on the inside. Now if you notice, looking at this rectangle, if I chalk this up into sections, into little squares, I figure out that in this rectangle there are 1, 2, 3, 4, 5, 6, 7, 8 different squares. So we're going to go ahead and say that the area of this is 8 square units, or 8 units squared. Now, a unit can be a centimeter, or a meter, or an inch, or a foot, or a millimeter, or pretty much any type of unit of length, right? So the area is just going to be in square units, so that's what we're going to say. The area is squarea. Let's go ahead and write that out real quick, all right, just so we all remember that area is squarea. And yes, you can put this in your notes. This is just a reminder that anytime that we have area, we'll be using square units. So examples of square units are like meters squared. The little exponent right there refers to the square unit. Inches squared. Feet squared. These are all examples of area. Alright, cool. Let's go ahead and go back to our book for a second and look at the formula for area. And this is the formula for any rectangle, or actually any parallelogram. So we have a formula for you guys. So we should remember that the area for any parallelogram is base times height, where if I have, that's a terrible shape. That's a terrible shape. I gotta get rid of this guy. Alright, that's better. Alright, so if I have the area of a rectangle is equal to the base times height, and here I have a perfectly drawn rectangle that the computer helped me draw. Alright, where if I have a base length of 5 feet and a height of 6 feet, I'd be able to figure out what my area is by simply multiplying 5 times 6. So all I'm going to do is multiply. Alright, if area is equal to base times height, and the base is 5 feet, and the height is 6 feet, I'm going to go ahead and multiply. 5 times 6 is 30, and feet times feet would be feet squared. And hey, look at that. Our area is squarea. So the total space on the inside of this would be 30 square feet. So area for parallelograms is mostly just multiplication. That's comforting to know. Alright, so let's look at our example that the book gives us. Find the area of a rectangular banner. Now notice they want to figure out the area of this banner, where it's 24 inches on the base and 4 feet on the height. The issue is that they're two different units. I can easily multiply two numbers, but multiplying units together, they have to be the same units in order for it to work. So I have two options. I can either convert them both to feet or both to inches. In this case right here, it looks like they decided to turn inches into feet, multiplying smaller numbers. And if 24 inches is the same thing as 2 feet, then 2 times 4 is 8, and we have 8 square feet. So most of this lesson is going to be multiplying two numbers together. We just have to be careful whenever we have two different units. All right, standards check number 1 gives us a question where we're trying to find the area of this rectangle. And it would be really easy just to multiply these two numbers, but I noticed that these are two different units. So I want to make sure that I convert them. Now, one important conversion factor you might need to remember is that 1 meter is the same thing as 100 centimeters. So I can say that this is the same thing as 100 centimeters. So if the length of the base is 100 and the height is 10, 100 times 10 is actually just going to be 1,000 square centimeters. Why? Because area is square area. Cool. Now what if we have a more traditional parallelogram shape? Now rectangles are super easy because they're just multiplying the base times the height. But what happens if we have like a slanted shape, like these parallelograms, where they're kind of like pushed to the side, they're kind of slanting or slumped over? Well, the same formula applies. Area is still equal to base times height, so area is still square area, but the height will always be perpendicular to the base, right? And it has to be that way. Here's an example of two rectangles or two parallelograms. This guy right here standing up straight, base times height, easy to figure out. Now this guy over here is a little bit slanted, right, and poorly drawn. Now the base is still the bottom, but the height has to be perpendicular to the base. And all I would do is multiply those two numbers together yet again. All right, so let's go ahead and look at an example that deals with this. Find the area of this parallelogram. Well, the base is 3.5 inches, and the height is going to be 8 inches. Now, some people might say, well, isn't this longer than 8? Well, yes, it might be. It actually is. But the height is only going to be measured from the base to the tippy top of the shape. In this case, 3.5 times 8 is 28. And because area is square area, the answer is going to be 28 square inches. All right, time for another example. Let's go ahead and look at standards check 2, part B, where this time I have a parallelogram that's kind of slanted. Now, which one is the base and which one's the height? Well, I'm going to go ahead and identify that this guy right here is the base, and the other guy is going to be the height. So if this is my base, I'm going to go ahead and put 3 inches there. And this is my height. I'm going to go ahead and put 8 inches in there. And 3 times 8 is 24. And because of our units, we're going to go ahead and put inches. And because we're talking about area, it's going to be inches squared. Not too bad. And that's it. All right. That is your lesson for lesson 10.1. where we talked about the area of a parallelogram. So let's go ahead and recap since we have a little bit extra time and might as well go ahead and go over a few things. The important thing for you guys to remember is a parallelogram is going to be a shape that has 4 sides. And then it's going to have 2 pairs of parallel sides. Parallel sides. Now, the formula that you're going to use is area is equal to base times height. All right, and this is going to be true for any parallelogram. All right. And whenever we have a slanted parallelogram, like this guy right here, the height will always be perpendicular to the base. Right? It doesn't matter if it's this way, it doesn't matter if it's slanted another way. We can always say that this is the base and this is the height. I think that's pretty much it. Just kidding. Actually, we did have a couple of unit conversion factors. I talked about this earlier, that 1 meter is equal to 100 centimeters, but also you might need to know that 1 yard is equal to 3 feet. This might be very useful on the homework. All right, go ahead and practice your homework, do your homework, and have fun.